Welcome back. Today we will be discussing the topic separation of homogeneous mixtures. In the case of homogeneous mixtures, as you know, the solute is uniformly distributed in the solvent. For separating homogeneous mixtures, there are four basic techniques: evaporation, crystallization, distillation and chromatography. So let's discuss them in detail. Among these, the simplest technique is evaporation. For example, you have salt water from seas. So you would have seen they would make boundaries and store the sea water and just elevate over there. The water will get evaporated and the salt will remain behind. So here what happens is, the principle they are using is boiling point. Water has a boiling point of 100 degrees Celsius. In the case of evaporation, we know that it does not require to reach the boiling point. It can evaporate at a much lower temperature. But on the other hand, the boiling point or melting point of salt is much higher. Therefore, water will get evaporated, whereas the salt will remain behind. Now, the salt thus obtained, it is not completely pure. It will still have some impurities. So, we use a little more advanced technique called as crystallization. Crystallization is a technique where we can obtain pure crystals from its solution. Take the same example of this salt. The salt that we obtained from seawater, this salt we can further dissolve it in water and make a solution. We have to make a saturated solution. So that is saturated, where the amount of solvent is less and the amount of solute is higher in concentration. We can heat the mixture a little so that it will get either evaporated or converted into vapor form and the crystals will start forming. The main difference between evaporation and crystallization is the solvent is evaporated from the surface. Whereas in crystallization, the entire solution is getting crystallized. In order to obtain pure crystals, we can go for a technique called as crystallization to get rid of the impurities. So what is the basis for this technique? The difference in boiling point of the solute and the solvent. The next technique is distillation. So distillation technique can be used when both are liquids, that is the solute and the solvent, both are liquids and both are miscible, which means that they are completely soluble in each other. For example, a mixture of water and alcohol, or water and acetone, or a mixture of acetone and alcohol. When we mix water with alcohol, it will completely dissolve. There is no distinction of layers. It is a homogeneous mixture. Here the criteria for separation is the difference in boiling point. So water has a boiling point of 100 degrees Celsius. Alcohol, that is ethanol, has a boiling point of 78 degrees Celsius. Acetone has a boiling point of 56 degrees Celsius. So clearly there is a difference in the boiling point. We can use this to our advantage. Let us see an activity to understand the concept of distillation. Now, there are two types of distillation. The one that we discussed just now is called as simple distillation, where there are only two components, water alcohol or alcohol acetone. There is a second type of distillation called as fractional distillation, where the number of components are many, more than 2, and the difference in the boiling point of these components, it is less than 25 Kelvin. Then we go for fractional distillation. In class 8, in the lesson coal and petroleum, you have studied about this, how to separate the different components of petroleum. Petroleum has many components like diesel, petrol, kerosene, butane, LPG, so many, gasoline. So we can separate all this from the petroleum mixture. How? By using the concept of fractional distillation. In fractional distillation, the only difference is that there would be an additional fractional column when compared to the distillation setup. In the fractional column or fractionating column, glass beads are present. When we heat the petroleum mixture from below, it will undergo vaporization, and it all collected at different levels separately. So let us now look at the activity of simple distillation.
This technique is used to separate two miscible liquids, that is a homogeneous mixture. For example, alcohol and water, alcohol and acetone. In this technique, we use the difference in boiling point of the two liquids. For example, if you want to separate water and alcohol mixture, so water and alcohol mixture, we take it in this glassware called as the distillation flask. This is your temperature regulated heating mantle. This part here is the condenser, and this is the collecting beaker. We connect the water supply to the condenser. This is the inlet and this is the outlet. So water from the tap will come through this. Here the temperature is cool. So for example, the boiling point of alcohol is approximately 78.3 degrees Celsius. Boiling point of water is 100 degrees Celsius. So we set the temperature at 79 degrees Celsius. So alcohol has a lower boiling point. It will vaporize first, whereas the boiling point of water is not reached. So the alcohol vapors, it will rise through this, and we have covered the mouth here. When the vapors rise through this, there is a opening here. The vapors will enter into the condenser. When the vapors enter into the condenser, the temperature here is cool, so condensation will take place. Vapors are converted into liquids, and the pure alcohol will be collected in this beaker, whereas water will remain in the distillation flask itself because it has a higher boiling point. That is our simple distillation. So when the components are many and the difference between the boiling point of the components is less than 25 Kelvin, then we go for fractional distillation. For example, if you want to separate a mixture of air, we can use fractional distillation. For separating petroleum, we can use fractional distillation. In a fractional distillation, you will have a fractional column. It will be packed with glass beads. So when the vapors rise up in the column, the ones that have lower boiling point will be separated at the bottom, and the ones that have higher boiling point will be separated at different level.
The last technique is chromatography. So the word chroma refers to color. For the first time, this technique was used for separation of colors in a dye, dye. Therefore, the technique is called as chromatography. This separation technique is used for separation of colors in a dye. A dye is a coloring agent. For example, we use hair dye or we dye the clothes with pink, red, purple color. These are coloring agents which are essentially chemicals. We can also use chromatography to separate the natural pigments. For example, in a plant leaf is green in color because of the presence of the pigment called as chlorophyll. Now, there are different types of chlorophylls: chlorophyll A, chlorophyll B, chlorophyll C, chlorophyll D, and other than this, there are other pigments also. For example, carotenoids, xanthophylls. There are so many pigments. Now, if you want to separate all these pigments present in a natural substance, that is leaf, we can use chromatography. This technique is also used to separate drugs from blood. So, the basic principle involved in separation of the components in chromatography is solubility. Some components are more soluble, some components are less soluble. Now, the simplest form of chromatography can be done using a paper, which is called as paper chromatography. There are advanced techniques also wherein we can use aluminium sheets for separating mixtures, and there are much more advanced called as HPLC, FPLC, high protein liquid chromatography, or fast protein liquid chromatography, wherein this technique can be used to separate different types of proteins present in blood or any other substance. So, what happens in chromatography, in paper chromatography? For instance, let us say you want to separate pigments present in leaf. Let us say there are 4 pigments, let's name them as 1, 2, 3, 4, and you want to separate them from this mixture. What do? You crush it and make a solution out of it. Right? For making the solution, we can use either water, we can also use ethanol or any other organic solvents. Now, next we take a paper. That's why it's called as paper chromatography, because the separation takes place on a paper. Right? So this solution I am going to put it over here, a small spot. That's it, a very very small spot. Then what do? This paper we are going to dip it in a beaker which contains a liquid. This liquid is called as the mobile phase, and the paper is called as the stationary phase, the one that does not move, whereas the solvent that is present here, it will rise up. The paper has got small fibers called as capillaries. When we dip the paper into this mobile phase, the solvent will start rising through the paper uniformly. When the solvent rises through the paper, which you will see in the activity, it will carry along with it this spot also. Now, what happens is there are 4 components present in our sample in the spot. Whichever component dissolves faster, it will be carried faster. Whichever component does not dissolve in this mobile phase or is not attracted to the mobile phase, it will move slower or it may not move at all. So when the mobile phase starts rising up, it will separate the components like this. So let us say this is component number 3, this is component number 1, this is component 2, and this is component 4. We get 4 spots. Now, from these 4 spots, what we can understand is, because this sample has moved the farthest. Why? Because it is easily attracted to the mobile phase. It is soluble in the mobile phase. This sample over here, it has not moved much. It has moved very less. Why? Because it is not complete. It is not easily soluble in this mobile phase. Thus, what we have achieved? We have achieved the separation of the four components.
So in this there are two important things. One is this paper that is called as the stationary phase, and in this glass cylinder we use a solvent which is called as the mobile phase. This is the component which will move, that's why it's called as mobile phase. This does not move, so it is called as stationary phase. So we can use different type of solvents for mobile phase. For this experiment I have taken water and petroleum ether. So let us start the experiment. So we are going to separate colors. I have taken a red color and a black color. So on the stationary phase we put our mixture, that is in this case ink. So not here, somewhere here, make a small dot, so that is your black color. Since we need a mixture, I am also going to use red color on the same spot. So our mixture or spot is ready. Now we will place this stationary phase inside the mobile phase. Make sure that the spot does not directly touch the liquid, only the tip should touch the mobile phase. And you will see that the solvent, it will start rising in the stationary phase. That's why it's called as the mobile phase. You will observe that the red color dye is slowly moving up as the mobile phase rises in the stationary phase. It will carry the red dye along with it. This is because the red dye is more attracted to the mobile phase, so it will move faster. Whereas the black dye is more attracted to the stationary phase, that is paper, so it will move slower. Hence you get separation of the two colors.